Today we're going to do Chapter 6, Section 4, Graphs of Sines and Cosines, but we're going to do Part 1, which is going to focus on slides 1 through 8. Okay, slides 9 through 17 will be in a Part 2 video, which I will upload at a subsequent time. So the first thing we have to do is sort of figure out where does the sine graph come from, right? We're going to start with a sine curve, and then we're going to focus on a cosine curve. And what I want you to think about is I want you to think about the unit circle. And when we had our unit circle and we had, a point over here at 1, 0, this was at, let's say, 0 radians. This was pi over 2 radians, and it was 0, 1. This was pi radians, and it was negative 1, 0. And this was 3 pi over 2 radians, and it was 0, negative 1. And when we asked you for the sine of these, we knew that when we were at 0 radians, right, the sine is the y value, so the sine was 0. When we're at pi over 2 radians, the sine is 1. When we're at pi radians, the sine is 0 again. When we're at 3 pi over 2, the sine is negative 1. And when we go back up to 2 pi radians, the sine is back at 0. And so if you look at it in these intervals, it goes from a sine of 0 to positive 1 to 0 to negative 1 and back to 0. And that's what this sine curve does up here. When the x-axis is in radians, and we notice that when we're at 0 radians, the sine is at 0. When we're at pi over 2, the sine is 1. When we're at pi, the sine is at 0. When we're at 3 pi over 2, the sine is negative 1. And when we get to 2 pi, we kind of complete one full cycle, and we're back at 0. And if we just follow the curve, we won't worry about those intermediate values, but you're going to see that this is one cycle of the sine wave. Now, this is an oscillating cycle. What happens is it keeps going forever, right? It's infinite in one direction, infinite in the other. But this is the basic wave. And notice it takes 2 pi units to complete it. So it's kind of like, think of, the period as the speed of that it takes, or the duration needed to complete the period. Okay, so the period is 2 pi of a basic sine wave. Up here, that basically it's saying this is the parent function, y equals sine of x, and they tell us from one rotation 0 to 2 pi. So they're just breaking it from 0 radians to 2 pi radians, and that's the only part we're asking to see. Okay, so that's where the sine curve comes from, and it has these very specific features. You're at 0 at the beginning, at the end, and in the middle. And then you're up one, up to 1 between the first and the middle, and then between the middle and the last, you're down 1. When you come to the graph of your cosine, okay, it's going to be somewhat similar. Again, we go back to that whole unit circle. We've got 1, 0 here at 0 and 2 pi radians. At pi over 2, again, we're at 0, 1. At pi, we're at negative 1, 0, and at 3 pi over 2, you are at 0, negative 1. Now remember, cosine deals with x values. So notice that at 0 pi, we start at cosine of 1, then we go to 0, then we go to negative 1, then we go back to 0, and then at 2 pi, we're back to 1. So from 1 to 0, notice from 1 to 0, from 0 to negative 1 down here, from negative 1 back to 0 up here, and then from 0 back to 1. And notice that in one rotation, one period of 2 pi, we do one cosine cycle. And again, it is oscillating, and it does continue, and you can go to the left as well. But what's interesting, again, is that your basic parent function of the cosine, y equals cosine of x, is going to have a period of 2 pi. It's going to take 2 pi radians to complete one cycle. And again, you want to learn the pattern. Unlike sine, it doesn't start at 0. It starts up at 1. In the sine wave, you cross the 0 3 times at the beginning, middle, and end. Here, you only cross it in the quarters. So again, I'm going to show you how to graph this on your own and things like that, but you want to memorize this pattern. So here we're going to talk about some important concepts in the equation of the sine. And you're going to see that, again, we've talked about the parent function being y equals the sine of x. And you think about it as 1 times sine of 1x, okay? We don't have those numbers in the basic parent function, but if we had other values, they would represent our a value and our b value. This would be our a there and our b there, okay? And again, in a cosine, same thing. It'd be a times the cosine of bx. And so very similar to the a when you're dealing with, if you remember in the quadratic formula, the a was very telling because the a really talked about, it was a vertical stretch or compression. It basically made your graph sometimes taller or squash, fatter, thinner, whatever. And it also, if it was negative, also created this reflection over the x-axis. And so that's going to be similar to what you're going to see, and we'll see that in the examples. The main thing of A is we use it to identify our amplitude, okay? So the amplitude of a graph, if I look here at a basic parent, I know that this is 1 and -1. And so the distance, when you think of it from the high to the low point here, is 2 units, right? Well, the amplitude is half of that distance. So the amplitude means that I'm going 1 up from this baseline and I'm going 1 unit down from the baseline. Okay, so the amplitude is half of the distance from the highest point to the lowest point vertically. And we find it by doing the absolute value of A. So whatever A is, you take the absolute value of it, and that's going to be your amplitude. Okay, the period, again, it says it's the horizontal distance of one complete cycle, and we sort of call it our speed. When we think of it as speed, basically it's how long it takes you to start and stop one full rotation. And the formula for it is 2 pi over b. So in this original problem here that I showed you on the previous page, the amplitude was 1. So the high was +1, or the max, let's call it the max. The max value was +1, as we saw on that sine wave. And the minimum was -1, okay? And because b is 1, the period was 2 pi over b, which is just 2 pi. And so that's why our period was 2 pi. But we're going to do some problems now with a different period and a different amplitude and see how that works. We're not going to worry so much about these steps. I'm going to walk you through these steps. You can read these, but I'm going to walk you through them anyway. So right now, if I want to graph y equals 4 sine of 2x, I'm going to create, first of all, my graph. So I'm going to create my graph here. Let me go down one more. Okay. And I'm just going to create it from this graph. Instead of drawing the parent graph first, I did that in class kind of, but I'm just going to graph it from here. And basically, I see that my amplitude, okay, in this problem, I see that A is 4 and B is 2. So I'm going to identify my amplitude, which is the absolute value of A. So it's going to be the absolute value of 4 or 4. So I know that my graph is going to go up 4 units. So I'm going to make that 4. Okay, so I go up by 2's there. I don't know why I did that point there, but I'm going to go up to 4, yeah. So it looks like that. I'm going to do -2 and -4. And my period is going to be 2 pi over b. That's the formula. And so it's going to be 2 pi over 2, which means my period is pi. So I know that my cycle is going to start and stop within pi radians, okay? So what I'm going to do is I'm going to break these into 4 quarters. And the fourth one, the final thing, is going to be the actual period, okay? I'm always going to put the period as this last one, and I know I start at 0. And so what I have to do at this point is I have to label these quarters here. Okay, so I'm going to identify what would those quarters be. And whatever I do to the right side, I'm going to do to the left because it is symmetrical to the left. So I know, well, not symmetrical, but the units are going to match to the left. So if this is pi 4 units over, this is going to be negative pi radians to the left. And now I have to figure out these quarters. So how I'm going to do it is I'm going to find my first quarter is going to be, I'm going to do a quarter of whatever the period is, which is pi. So a quarter times pi is pi over 4. So I know this is pi over 4, and this one would be negative pi over 4. The next one I'm going to do would be half of pi, which is pi over 2 radians. So this is pi over 2, and this is negative pi over 2. And the third one is going to be 3/4 pi, 3/4 times pi, basically 3/4 times the period, which is 3 pi over 4. So 3 pi over 4, and this is negative 3 pi over 4. Now that I've labeled it, I know what the sine wave looks like, and I'm ready to graph. So how the sine wave looks, I know, is the sine wave starts at 0, 0, right? It goes up to its peak here, it goes back to 0, it goes down to the minimum, and it goes back to 0. And so my sine wave should look something like that, okay? And on the other side, it just goes, this is the minimum, this is the 0, this is the maximum, and I'm back at 0. And this wave goes like that. And I'm going to do arrows because I know that this wave actually continues to infinity. So I know this is kind of a weird drawing, but so let me just do it with the pencil, but like that. Okay, and so again, and it's oscillating, and I know it goes on to infinity, but I only need to show 2 periods of the wave. And I usually do one to the right of 0 and one to the left of 0. I find it to be the easiest. And that's how we create this wave. Our amplitude is 4, which makes sense because it's 4 units above the base and it's 4 units below. Makes sense. My period is pi, which means I start and I stop. I do 1 full revolution within pi units, which is exactly correct. And that's it. That's how we graph the sine wave. So let's graph this one. This one has a few different changes in it. This is a cosine wave. So again, I'm going to set up my graph. And I know that I'm going to need to have this in quarters. 1, 2, 3, 4. And let's see. I know that my A value is -2 and my B value is 2/3. And so I know that my amplitude is the absolute value of A, which means the absolute value of -2, which is 2. And I know that my period is going to equal 2 pi over B. So 2 pi over 2/3, which when I do the math ends up being 6 pi over 2 or 3 pi. So my period is 3 pi. So I know since my period is 3 pi, I know I'm starting at 0 radians and I'm going to 3 pi radians. And I'll have -3 pi radians on this other side. Now, I need to figure out what these quarters are going to be in between. So I know that I'm going to have to do a quarter times 3 pi, and that's going to equal 3 pi over 4 radians. So this is 3 pi over 4 and -3 pi over 4. Then I'm going to do a half of 3 pi, and that's 3 pi over 2 radians. So that's this one, and this is negative. And the last one is 3/4 times 3 pi, and it equals 9 pi over 4 radians. And this is -9 pi over 4 radians. And so now I have that. My amplitude being 2 tells me that the highest my graph is going to be +2 and -2, right? And so I'm pretty much ready to do a cosine wave. The only problem is I see that this is negative, which just like a in the quadratic function, if it's negative, I'm going to have a reflection over the x-axis. Well, this is going to be reflected. So if I was to graph the basic cosine wave without the negative, I know that I would have started up here. I would have gone through 0. I would have gone to my minimum. I would have gone back to here, and I would have gone to here, and my graph would have looked like this, okay? And on the other side, I would have done the same combination, knowing how my cosine wave works, and I would have this. Now, this would be the graph of y equals 2 cosine of 2/3 x, but that's not what I have. What I have is negative. And so basically everything that's at 0 is going to stay at 0 because you can't flip over 0, right? But all my other values are going to switch, okay? These low ones are going to go up, these high ones are going to go down, this one's going to go up, and this one's going to go down, as will this one. And so I realize that what I've got here is this reflected graph, right? And here. And so the red graph is the actual graph that I'm looking for this. It is the reflected version of 2 cosine, right? So I need this one. And there we go. And so this is the graph that I'm actually looking for, okay? And so, again, if you know your general wave, then it's easy for you to, easily reflect it. And do this, okay? So the negative can bring a little bit of a challenge, but again, you want to understand that, whatever your max and min value, that's what's going to be the value at x, is 0 radians. Where you end, you're also going to end at that same spot. In the middle, you're going to be at your high or your low point, and then these in between, these quarter marks, 1/4 and 3/4, are going to be your zeros. So we're going to do another one. We come over to here. We've got, notice, another reflection, right? So A right now is -1/2. B is 3. And so I come over here, and I know my amplitude is going to equal the absolute value of A, which is absolute value of -1/2, which is 1/2. And the period is going to be 2 pi over the B value. So it's going to be 2 pi over 3. So again, I'm going to come and I'm just going to draw this out. And I know that I'm going to need to do, I want 2 periods. So I'm going to, use both sides of the graph. And I know that I've got to break this into quarters on both sides. And I know that this period is going to be this 4th quarter, okay, where the rotation ends, or the cycle ends, or the period ends rather, right? So that's 0. This is going to be -2 pi over 3. And so I need to figure out what these intervals are going to be. So again, I'll start 1/4 of 2 pi over 3 equals 2 pi over 12, which is pi over 6. So this is pi over 6, and this would be -pi over 6. 1/2 of 2 pi over 3, that's going to give me my midpoint. That's 2 pi over 6, or pi over 3 radians. So this is pi over 3 radians, and this is -pi over 3. And 3/4 of the way through the period is going to be 3/4 times 2 pi over 3, which is 6 pi over 12, or pi over 2. So this is pi over 2, and this is -pi over 2. So I have my 4/4. I know my amplitude is 1/2, and so let's say this is 1 and this is -1. I know that this would be 1/2 and -1/2 here. And so now I'm ready to really graph my graph. Now I see here again, this is a negative, so I have to think to myself, if this was positive, right, I know that my sine wave would look something like this. I'd be going to here, it would go to there, right? I would go down here to the -1/2, and I'd go back up, right? And that would be my wave. And over here, it would be here and here, and here, and here, and I'd have my wave. Well, again, remember that here what we're doing is a negative, so it's the reflection over the x-axis. So my zeros are going to stay the same. Okay, that's not going to change, but my other points are going to reflect over this x-axis. And so my graph is going to look a little bit different. And so my graph is going to be the reflected version of this. And so the red graph is actually the graph, whoops, that I'm looking to do here. So it's the red graph. So the blue graph would be the positive version of this, and the red graph is the negative. And there you go. Okay, and so pi over 6, and this is pi over 2. Okay, and so that's the graph for this. So again, you want to focus on the amplitude, your max and that's your max and your minimum value of your graph. In this case, your period, which is the duration or the speed at which it takes to get through one full cycle. And then if it's a negative, it's a reflection over the x-axis. This is where we're going to stop part 1. And so anything after this slide is going to be part 2.